Hi student. So next, I'm going to show you how to solve a letter, how to obtain a letter inside equations. There are many examples here. My goal to give you as much examples so that you can go home and work on a homework, so at least you have something to help you out. So if you look at my lecture note on page 91, you will see a summary describing about the solving a formula for a given letter. It has 6 things right here. I'm going to reading this over quickly for you, okay? To solve a formula for a given letter, identify the letter. And first, multiply on both sides to clear the fractions or decimals if necessary. 2. If parentheses occur, multiply to remove them using the distributive law. 3. Collect like terms on each side if necessary. This may require factoring if a variable is in more than one term. 4. Using the addition principle, get all terms with the letter to be solved for on one side of the equation and all other terms on the other side. Collect, this is number 5, collect like terms again if necessary. 6. Solve for the letter in question using the multiplication principle. Now, we have a lot of them we have actually applied in section 1.1, and some of them in the example I just showed you previously in the example for exercise number 38. But this time around, we're going to work on these a lot. So make sure you have this kind of handy or something in mind. So just to help you, a suggestion when you solve an equation, what should I do? Should I add something on both sides? Should I subtract something on both sides? Should I multiply something on both sides, or dividing something on both sides? Or when I see parentheses, what do? I need to remove parentheses by distribute the coefficient to each number inside parentheses. So make sure you know that. Or sometimes the letter or the variable you're looking for happen to be more than one terms. What do? You need to combine those 2 terms together as one term, okay? Because the goal is to solve what is that letter is. For example, 1x, 1t, okay? So let's start with example. We'll clarify a lot of things, so you may have questions. Here's the example. This is exercise number 2. Solve for the given letter D equal to RT for T. So we're given this equation, a formula, D equal RT. We're looking for T. Solve for T. Solution. The only thing difference with the previous section now is that you see more variables inside an equation, okay? And again, the formula models the relationship between variables, okay? So it's looking for T, so we solve for T. So we need to solve for T. The goal is T equal what? Again, we need to looking for 1T, okay? 1 times T is T. This is R times T. So to eliminate R, we need to, remember this is multiplication, right? R times T. So the opposite of multiplication is division. So we need to divide both sides by R. Okay, because we're looking for T. So dividing both sides by R, we get D divided by R equal to, R divided by R is 1, so 1 times T. So 1 times T is T. D divided by R is D divided by R. Again, we're basically almost done. I just want you to write what you're looking for on the left. So T equal to D divided by R. Just rewriting it. So this is the answer for this exercise number 2. And then I have another example, exercise number 10. Similar question, just different formulas. So let me erase this. So this time we're given a equal to a plus b divided by 2, and we're solving for b. Okay, so let me rewrite the original formula. A equal to a plus b divided by 2, and we want to solve for b, which is right here. Okay, now this is a little bit tricky than the previous one because this time b is with another variable, okay, and divided by 2. So b stuck inside one fraction, right? This is one fraction. B stuck inside. We need to get b out of the way, so b equals something. Okay, that's what we're looking for. So how do we do that? Make sure I stick with my note. So let's see. So I have it here. Know that this right-hand side, we can rewriting it by factoring out this coefficient, something divided by 2, right? It has to be 1/2. You can factor out 1/2 times a plus b. Okay, so you can factor this coefficient separate from the variable on front of it. 1/2 times a plus b. Rewriting the left-hand side. Now, remember, you try to get b. So the coefficient you're looking for is 1b. Okay, so far you have this. What is the coefficient of b for now? If you distribute, right? If just for checking, I'm not going to distribute. I just want to show you what the coefficient of b is. If you multiply 1/2 to a, you have 1/2 a, right? And same thing, 1/2 b. So that means the coefficients of b is actually 1/2. You see that? I hope you see that. So that means we want to eliminate or change this coefficient 1/2 to 1. So 1/2 times what is 1? 2, right? So we can multiply 2 both sides. 2 times 1/2 not capital letter, a plus b. So simplifying, we have 2a. 2 times 1/2 is 1 times a plus b. Okay, we're almost there. Simplify again, we have 2a. 1 time so anything is that anything. So a plus b, you can drop the parentheses. Now we're almost there. We're looking for b, right? Now b this time is added to it the constant sign. This time b is part of the sum of a plus b. So we want to solve for b. We want to isolate the b by using the not the multiplication. This time the addition principle. So to solve for b, we need to remove this, change this term to 0. So a plus what? Make it 0. Subtract a, right? Because a subtract a is 0. And 0 plus b is b. So that's what we're looking for, b equals something. So let me continue from here to here, okay? So 2a, so I'm going to subtract a on both sides, equal to a plus b, subtract a. Okay? Simplify again, we have. Now, make sure you see that these two variables are different. Okay? This is capitalized letters, a. Okay? They are different. They're not the same variables. So, do not combine them, okay? You combine them, it's wrong, it's incorrect. So 2a minus a equal to simplify as much as possible, we have common, or we have like term right here. A subtract A is 0. Don't forget the B right here. And then simplify further, we have 2A minus A equal to 0 plus B is B, which is what we're looking for. Okay? And just the last step, rewriting B equal to 2A minus A. And we're looking for B. So this is the answer. Let me check to see. So we get B equal to capital A subtracts A's. Okay? And you can see it is different. And by the way, this is the average formula, okay? It means average of two number, okay? You can think about A is the first number, B the second number, divide by 2 because two numbers, okay? That's why this capital A's is different from this, not capital A's right here. They are different. Okay? So let's see if I have more example. Yep, I have more example here with the same question, just different formulas. All right. Next one is number 16 in your book. Oops, sorry, I should have corrected this too. Apologize for that. This is number 16. E equal to mc squared, and we solve for m. Okay. So let me be writing the equation. E equal to mc squared. We want to solve for m, the letter m. And again, m, if we want to solve for m, right? That means we want m equal something. So we have to have 1 times n or 0 plus m. Okay, depend on its coefficient right here, or the term is with. This time we have m times c squared, right? So we need to get m. That means we need to divide both sides by c squared, right? Because if we divide c squared with c squared, we get 1 times m, which is what we're looking for right here. So we have e divided by c squared equal to c squared divided by c squared is 1 times m. Okay, simplify further, we have, this is just from the left hand side. They're different, you cannot simplify, so just leave it as is. 1 times m is m, and rewriting, we have m equal to e divided by c squared. Okay, make sure you write the answer as m equals something because we're solving for m. I hope it's helpful with all the example and it will prepare you for the homework. Let's see. All right. I have another different example. Same question, different formulas. For this one is number 26. Okay. And here the equation is t equal to 1/6 times x minus y plus z, and we're solving for z. Alright? Rewriting the equation, the original equation, we have t equal 1/6 x minus y plus z. Now, we want to solve for z. Our goal is z equal what? At the end, okay? Either 1z or 0 plus z at the end. Now, again, what the coefficient of z is? Remember, last time I showed you in the previous example, you can verify its coefficient by looking for whatever coefficient in front of it. For this time, it's inside parentheses, right? 1/6 is. So if you distribute, right? I'm not going to distribute. I'm just trying to show you what coefficient of z is. So if you multiply 1/6 to each term inside parentheses, right? You see that 1/6 is the coefficient of z. 1/6 is the coefficient of z. So 1/6 times what equal to 1? Sorry, 1/6 times what equal to 1? Because we want to change its coefficient from 1/6 to 1. 6, right? I hope you see that. So we know that we have to multiply by 6 on both sides. Okay? Let me clear this out because I'm not planning to distribute. I mean, you can. There are different ways you can approach solving this problem, but it's more efficient that you change this coefficient right here, which is fraction, into a whole number first, which is 1, so that you don't have to deal with fraction. If you multiply this 1/6 right here to each term, then you will solve this problem with fraction coefficients. I mean, it's fine. It says to be careful. With fractions, you just have to be careful. So let's multiply by 6 on both sides. 6 times t equal to 6 times 1/6 times x minus y plus c. Okay? So let's see. We have 6 times t is 6t equal to 6 times 1/6 is 1. 1 times x minus y plus c. Okay? Remember, I'll go to solve for z. I put it near the end, okay? So 6t again. 1 time any number is that number, which is x minus y plus z. Alright, we need to solve for z. Again, z is add with the two terms, x minus y. This is adding, right? So we're not going to use the addition principle. We're going to use the, this is adding, right? We're not going to use the multiplication principle, okay? We are going to use the addition principle because z is adding with something or subtracting something, okay? So I'm going to use the addition principle to solve for z. So I'm going to subtract. I want to turn, my goal is to turn these two terms to 0, okay? My goal is to make these two terms to 0 because 0 plus z is z, right? So how do I do that? Using the addition principle. Are you with me? If I am subtracting x on both sides, because x subtract x is 0, right? And don't forget to subtract x from both sides. That's the addition principle. And because this is negative y, right? Negative y plus y equals 0. Plus y, right? Same amount, opposite side. Once you're adding, make sure you're adding on both sides. Okay, so that's the plan. We are going to subtract x from both sides and adding y to both sides of the equation. Okay, so let me show you. 6t minus x plus y. Okay, 6t minus x plus y equal x minus y plus z minus x plus y, okay? Now, simplify it as much as possible. And our goal is to get z on the right hand side. That's why we subtract x and plus y, just to cancel the two terms, add with the z, using the addition principle. These three terms are different, so you cannot combine them. So leave as is. So I just copy again. 6t minus x plus y equal to, looking for like term and you combine, okay? So x, there's another x here. X subtract x is 0. Okay. Subtract y, negative y